Okay, guys, so now we are starting with today's daily Leetcode problem. So this is GCD of string, right? Greatest common divisor of a string. Um, it's an easy problem, rated as easy, but still you can see how many legs are there. So it's a good problem, kind of a good problem. So you have been given two strings, a like S1 and S2, and then what you have to do, you have to find a string T. A T should be a string which divides S. What do it mean by division? Like S should be equal to some combinations, or not some combination, but some repetitions of T. So you can form S as some like T plus T, or you can form it like by using three T's, and T is concatenated by itself one or more times. So given the two string S1 and S2, you have to return the largest such possible string T such that it evenly divides S1 and S2, which means like if this is A, B, C is T, all the possible strings that you can generate by using this is like first ABC, then again ABC, then again ABC, and you can so on, like have multiple repetitions of ABC. So your given string, like both the string has to be multiple of ABC. Then the you can say that yeah, ABC is like yeah, it divides it. You have to return largest such possible. Like in this case, if this is only just, let's say, S1, right, and S2 is something like let's say three multiples of ABC, right? Or let's say two multiples of ABC. In this case, like S to complete is basically dividing this also like this and this also. But if you take three ABC, can like 3 ABC can divide this as 2, okay, fine, but 3 ABC cannot divide this, like only 2 ABC can divide, because this is 4 ABCs, so 4 or 2, the maximum one would come out as 4. Like in this case, same thing is happening, like AB 3 times, but AB 2 times. So you cannot have AB 2 times. Why? Because for AB, having AB 2 times, you this AB will not get divided by that, right? It's a little complicated in terms of that, but it's straightforward and like simulation problem. As you can see, related topics are maths and string, and that justifies it also. So like there's just like yeah, simulation. You have to try for each, and test cases are also very small, so that's why it's easy. So you have to try for every possible T. You have to try for every possibility. So I'm trying for, first of all, let's try for like yeah, you can pick any one of S1 comma S2, and then say like yeah, then keep on reducing this. For example, you take this complete as a T. Okay, so for example, if this is S1 and S2, like if the size is different, then it's better to take the smaller one as the initial T, because obviously only smaller one can divide the smaller one. This bigger one cannot divide the smaller one, right? So T is equal to ABC initially. So let's try for ABC if it's fine or not. Okay, let's say if it is not fine, let's say this is AB B and AB, like AB, right? AB, and this was just AB and AB. So like second case I'm talking about, yeah, exactly. So in this case, you can try with AB. You will see it's not fine. Okay, then you will say ABA. Is it fine with ABA? No, it's not fine with ABA. Then you can say like AB. Is it fine with AB? Yes, it's fine with AB. So then you can just return AB. Okay, there are multiple ways to do it as well. I like yeah, that's what I did. Like basically, I check for the size of a string, which size of a string is good. Like because let's say the size is also very important, like the size of T. Let's say in this case it's 2. It's very important because you will have multiple repetition of this string. Like in this case it's 2 to 2, and in S2 is equal to 2 2. So by selecting a size, you selected the prefix part of that size, right? Prefix part of that size must be equal to this. Okay, so then after selecting size, what I did, I checked that this size divides both of them like evenly or not, whether this divides or them or not, because size must also divide for string to divide. Then I created a kind of a set to check like every division of size 2, like AB, and then the next one is again AB, and then next one is again AB. Like all these divisions should contain the same value, like in this case also AB and AB. So pushing all of them. So ST is the starting point. You can have multiple starting point. First you have a starting point as index 0. Like in this case, you have starting point as index 0, then you have starting point as index 1, no 1, but you have starting index at 1 to 2, then 3, and then 4. So this is also increasing by the same length, and then selecting the string which is s1 dot sub str starting point and the length, and pushing into set, and then checking the set size equal to 1, which means like all elements are equal to this. So you can say, yeah, it's you can return as soon as you get any one of them, because I'm going like from maximum size to minimum size. So you have to return maximum size, so you return in the first go. The next way of doing this problem would be, I submitted this also earlier. The other way of doing this problem is like going for yeah, you can say going for all length, but yeah, because length fixes your string. So n minus 1 I plus plus string, like check for, this is string check, check string is my like s1 dot or s2 dot sub str, let's say this n, right? 0 comma n, which means sorry, 0 comma I. I'm trying for the string having index length I. What is n? N is obviously s1 dot size, because I'm seeing for s1 currently, but like we will validate up to s2 also. Then I'll check if it's good, like if this like what this string check is good with respect to your s1, okay, then fine, and it should be good with respect to, check should be good with respect to your s2 also. Then you can say return 1, not return 1, return check, because yeah, that's what it is. And return otherwise not 0, but just yeah, empty string in all other cases. Now check function, oh sorry, bool good function is very simple. String b, and then you have to check whether b is equal to overlapping multiple repetitions of a or not. So you will say key, you can do it in multiple ways. The like one way is to create a different string while just checking, while x dot size is lesser than b dot size which you want to create, you will say key x plus equal to a. That's about it. Return whether x is equal to b or not. At that point, it should be equal to b when the size is not lesser than that. When it becomes equal or greater, it should not become greater, obviously. So you're slowly adding up to x. So for example, your b x was like just a b in this case, and your b was a b a b a b. Like a was a b, and you are checking for whether a b like yeah is a good divisor of the string, like three ab's. Yes, it is. So how you'll check that, you'll say key, okay, push one ab, is it equal to and then whenever the size is less, another ab and another ab, now the size is equal, you can say like x equal to b, return this. Let's try to sum this up. Need to comment this as well. TLE percent. Let's check, this was the summation. It should not happen TLE for small cases. Okay, s dot substr, I think n minus I you should go for. Why? Because I want maximum size. So first I'll try for maximum size n. Yeah, now it's working. Yeah, because there is also one issue, like it cannot be equal to 0. 0 is like not defined. You have at least one. So yeah, I think n minus I would be fine. Just let's start some of this up. This implementation is easy, but yeah, more time consuming and less fast. But the previous one which I showed you, key to check for all the length, and then yeah, check for basically all the length. Basically, in this first for loop, I'm generating I is equal to length, which is equal to minimum of size. Obviously, you won't want this won't help you in the some like worst cases when both sides are equal. But yeah, in some cases you can just go with minimum first and then keep on reducing size, and then checking whether this divides evenly or not, and then checking whether it is completely equal to or not. So this thing which I'm doing over here using this, something like this I'm doing using set, like all the repetitions should be same. So all the strings of size 2 should be same. Then you can say 2 is a good divisor of the string length 2. Yeah, prefix of length 2 you can say is a good divisor. Okay, so that's how. Now let's move to the G problem of the day. This one is pretty interesting and good problem. We can discuss this in the same video because this is a nice problem but is a kind of a standard one. You have been given rows of n houses. Okay, there are n houses in a row. Each house has to be painted with one of the three colors: red, blue, green. Cost of painting a house is given to you, like r contains the cost of R array contains the cost of painting the given house present at ith index by color red, right? And similarly, blue and green. The cost of painting houses is different, so you have to paint all the houses. And there is only one condition: no two adjacent houses have same color. Return the minimum cost. You need to paint all the houses, right? So you have to paint all the houses. So basically, you have to go from index 0 to last index n and like painting, and you should not use the color which you used previously. So there is another thing to look up for. That's why it's 2 dp, but yeah, there are only three colors, so yeah, less time complexity. So in P, I'm storing what is the previous color you used, like on the previous house. So the next house, you cannot use the same color. Iterating for all the possible colors, 0, 1, or 2. I should not be equal to P, and then selecting minimum of them, like after, not minimum of them, but after this point, which one gives me minimum overall. So then returning that into. So you can think this is a kind of a standard DP problem, right? Basically, matrix DP problem, 2D DP problems are like this. You have to go from first row. Okay, so in this case it would be something like you have to start from any point in the first column and then go to any point in the last column, right? But you cannot take same column simultaneously, but it happens with a row. Like the row wala question was a standard one, so that's why I created this first. Like I created converted this matrix into uh, let's say given over here the transpose of this, because RGB values are given to you, but I for each index for each I converted this into something like v dot pushback rigibi. So this three values are not in my column. This are my in row. So if you see, like this vector is basically n cross 3. The given vector is 3 cross n. There are only 3 rows, but there would be n columns. And yeah, n columns. In my converted vector is n cross 3. There would be n number of rows, but only 3 number of columns. So you have to start from the first column, first row, which is for first house. Color it with any color. Just remember that color. Don't use it in the second house. So this is standard DP problem. Solve function 0 to b, and this is the base cases. When it goes beyond the limit n, you return 0. This is just rememoration part. R is equal to 118, some wax number, because you want to return minimum. These are the three options. This should not be equal to previous one, and R is equal to minimum of R comma. Just add whatever the cost you have to add for this point, and then make I is equal to your previous, so that the next one will not color same as I, and return dp of id comma p. And this is like the only good thing about this is, because initially you cannot pass it previously as a 0, because you can't say that okay, I colored it with color 0, or for that matter you can have something like 4 colors. You can go for 1 to 4, and then you can just say ki, okay, make it equal to I. Hmm. But then for each index you have to add 0. For each index you have to add 0. These are the cost of coloring it with 3 colors. But yeah, that is fine, but increase so much space complexity, because this whole 5001 gets multiplied, like not multiplied 4 times. Yeah, it's now previously multiplied 3 times. Now it's multiplied. Basically, why I did this? This is the question. Why I did this? I generated basically a previous row where no one is printed, no one is painted, and and then I initialize this as my zeroth. Let's say this row is painted with 0 color, right? Yeah, red color you can say, and then you have to move to the second thing, and then you cannot use that one previously, just for this negative index, because you can say that For a zeroth, what you're passing here, all colors are allowed. Okay, all colors are allowed for zero. But if I pass zero over here, minus one over here, that all color if I pass zero over here, then this would create a problem because I'm going from zero to three. So you cannot use the zeroth color at the third like, yeah, in the first in the first house you cannot use that zeroth color because he will see that previously is stored as zero, like, but previously he don't know that previously there was no house, so this is my first house, right? Okay, so how you can do that? Okay, there is another thing. Okay, I think you don't need to do this. Over here we can eliminate this kind of thing. This was that, this was three. Okay, fine. Only thing is like, p you can pass. Okay, you can still pass zero, you don't need to pass minus one because there is only problem when you pass minus one. dp of like indexing don't cannot be minus one, right? And then and condition I can apply over here. That's what I'm saying. id is less than, not less than, id is greater than zero. And so that's about it. And then what is equal to minus one three. I think it should be fine. Let's try to sum this up. Just remove this n into 3 and then v dot size id p. What's this? That is the issue. P and id is not equal to 0. Oh, id is equal to 0. It will not go into this. Oh, instead of that, what we wanted is id of 0 or. If id is 0, then go into this. Like, yeah, directly go into this. You don't need to even check for this previous colors. Yeah, now let's try to sum this up. 1e18 because long they are asking, so initialize hearts, then so I use long over here. Okay, perfectly fine. So this is about standard matrix dp problem. That's about it. Bye.